Okay, so let's write the entropy balance equation that we have over there. Let's write it and let's investigate what it is referring to. What does each term mean? So I have delta S from 1 to 2 is equal to the integral of del Q over T over the process 1 to 2 plus S generated from 1 to 2. All right? This is the entropy balance for a closed system. Now let's investigate what the terms mean. The first term is the easiest. The first term represents the change in entropy of the system as it moves from state 1 to state 2. So our system moves from state 1 to state 2. So delta S refers to the change in entropy of the system as we go from state 1 to state 2. System change in entropy S2 minus S1. So the system starts off with an entropy S1. And it goes to state 2 with an entropy of S2. That's what the first term means. It's your familiar delta E, delta P, delta T. Remember, we've hypothesized that entropy S is a property. So we're going to treat it like a property. S is a property, and delta S from state 1 to state 2 is S2 minus S1, okay? Where S is a property. The next term here, this guy, this represents the entropy transfer due to a heat interaction. S transfer due to heat transfer. Now the temperature T here, what temperature am I talking about? I'm going to put a little subscript right here, INT. I'm only going to do it for a little while. I'm going to leave it after a while. I'm going to drop it. I'll probably get sick of writing it. But what is this TINT? What is this temperature in the integral? Well, this is the interaction temperature. It's the temperature of the system at the point where the heat is transferred to the system. So if we have a system here and heat is getting transferred in, Q. So this is my system here. This is my system. If I stick a thermometer right there, the temperature at that point where the heat flows into the system is the interaction temperature. So T int equals, quote, interaction temperature. Interaction temperature. So temperature at the location where the heat is being transferred into the system. You stick a thermometer right there on the system boundary where the heat flows in. That is your interaction temperature. Okay? And then we have the third term here, our new term, the weird term. This represents entropy generation inside the system over the process due to irreversibilities. So this is S generated in system due to presence of irreversibility. So if there are irreversible processes within the system going on, unrestrained expansion, friction processes inside of our system, heat transfer across a finite temperature difference inside the system. That'll show up as an S-gen, positive S-gen in our entropy balance. Note, S-gen, remember, S-gen can either be 0 for a reversible process or positive for a irreversible process. Entropy can only be generated, it can't be consumed. So S-gen is always positive.